Hi, everybody. This is Dr. William Boone, and I'm going to show you some basics about Wright Maps. I've worked in Rasch for over 30 years. I received my Ph.D. with Ben Wright at the University of Chicago, and I'm the author of two introductory Rasch books, Rasch Analysis in the Human Sciences and Advances in Rasch Analysis in the Human Sciences, published by Springer. So this will be a quick tour, a quick introductory tour to Wright Maps. So on the screen, you will see I have a spreadsheet for a multiple choice test. The first two columns, the first column is an ID number. The second column is gender. Then you can see I have a total of 12 multiple choice items in this test. And the items were scored as a 1 or a 0. 1 means the student got it correct. A 0 means they got the item incorrect. So this is a classic way to organize your multiple choice test data. Now what I'm going to do is I'm going to show you the control file for Winsteps that I created. And in another video, I'll provide you with a YouTube video showing you how to create the control file. But for today, I'll just show you the control file that we have. And I'm going to share that. And if you look at the screen right here, you can see the control file that I made. The first third of the control file are a variety of different codes that helps Winsteps run. The middle third are the names of the items. Notice these are the same names that were in the Excel sheet. And then finally, at the bottom of the control file is the data for the test that I just showed you. When you're looking at the data for the test in the control file, you see the answers for people to each item. Then you see the ID number. Then you see the gender. So I've shown you the spreadsheet and I've showed you the control file. Now we're going to run Winsteps. Double click on Winsteps. We do not need to create a control file. We're just going to run it, hit no. Then you hit enter on your keyboard and you find your control file. And I have the control file here, CF MC test data. I'm going to run it. Hit enter on your keyboard, hit enter on your keyboard. And now you've run Winsteps. We're going to our Wright Map table, table 12. I'm going to pull it up, make it big for everybody. Now we get to the real fun part. So I'm going to help you learn how to interpret this Wright Map. I am a little biased, but I really prefer Wright Maps that are set up vertically. I feel that it looks like a thermometer. People are familiar with reading thermometers, and it's much easier to interpret. So certainly there's some Wright Maps that are set up horizontally, but I would encourage you to set up a Wright Map vertically. We're not going to talk about everything in this diagram, but we're going to talk about the key components. On the right-hand side of the Wright Map are the items, and these are organized by the item difficulty, the logit value of the item. So what this means is on our Wright Map, item 12 is the hardest, and item 2 is the easiest. So we have a progression from item 2 up to item 12. Those are our items on the right. On the left-hand side of the plot are the people who took the test. Each hashtag represents 2 students, and each dot represents 1 student on this plot. The higher performing students are on the upper left top of the plot, and the lower performing students are at the base of the plot, lower left. So higher ability students at the top, lower ability students at the bottom. We can change it so that Winsteps plots every person, and this is at least the way it is when you run it straight from Winsteps, but you can change it so that you see a hashtag for every person. All right. Now, the important thing that you want to think about as you're working with your Wright Map is, first, let's look at the items on a Wright Map. from the bottom, item 2 to item 12. Notice these gaps. So between item 7 and item 6, there's a gap. There's a gap between item 10 and item 8, a small gap between 1 and 5 and 3 and 4. These are areas where our measurement instrument is a little weak. Maybe we would write some additional items for our test. We would collect some more data and we would create a Wright map. And we'd like to see if we could fill the gap in those gaps. Certainly, if we're missing items here, it degrades the measurement functioning of our instrument. The other thing is, from a purely measurement perspective, areas where we have items that are nearly the same, item 1 and item 5, item 3 and item 4. Actually, we only need one of those items, 1 or 5, 3 or 4. So that's a way to shorten a test. And if you're trying to fill the gap with new items, those might be candidates that you would remove. Okay, now let's go look over to the left side where the people are. We see how the people are organized on our Wright map. Again, there are low performers on the lower left and high performers on the upper left. And then if you've read a little bit about Wright maps, you will know that, for example, if we go to these 1, 2, 3, 1, 2, 3, 4, 5 hash marks where the S is, those represent, that location represents the measure of those people, how they did on the test. If we draw a horizontal line across the Wright map, we would then say that these people would have more than a 50-50 chance of correctly answering the items below the line. And we would say that these people have less than a 50-50 chance answering the items above the line. So what's very powerful about the Wright map is we can look at particular people and we then could say what our prediction is as to how they would perform on the test. Okay, the last thing, or the last two things I'm going to mention to you today is these items on the Wright map, we just have their item names. What's very, very useful for you is if you type in something about the content of the item. So type in the content of the item for each of these items. And then you look from the bottom of the Wright map to the top, and you want to look for patterns. Does the pattern going from easy to hard make sense? Does it match some theory that's been proposed? There's been a lot of work done with Wright maps where people try to interpret the ordering and the spacing of the items. In some fields, for example, science education, people refer to that as a learning progression. So that is your quick Wright map introduction. And maybe the last thing I would say is this plot that we get from Winsteps is beautiful, but what I would recommend is for a publication is that you actually look up the values of each of these items, and then in some nice program, some word processing program, some sort of art program, you make a beautiful Wright map where you have a solid line going vertically, you have the location of the items, and you have the logit values. And then also, depending on what you're going to do, you'll have the people. And maybe what you do is you only include this location of the mean item difficulty and the mean person ability. So those are the key things on this quick intro to Wright maps. I encourage you in your work to use vertical Wright maps. I encourage you to present those in your papers. And I encourage you to really spend time making your Wright map as user-friendly, putting in information about the different items on your Wright map, and then finally in your papers, discussing the ordering and the spacing of the items, trying to match that with theory and to see what you can discover that's new. Okay, thanks everybody, and I'll look forward to presenting some other videos for you.